Welcome to The Explainer. Today, we are pulling back the curtain on firewalls. We're going to get into the strategies, the different ways you can build them, and some of the really clever ways attackers try to get around them. So, to really get a handle on how firewalls work, let's start with a really simple question. Imagine you're a guard at a gate. Someone walks up. What do? Do you check a list of people who are banned, or do you check a list of people who are approved? Your answer to that question, well, it changes everything. You see, that choice isn't just a small detail. It's the foundation for two completely different security philosophies. This is what it all boils down to, these two core strategies for our digital gatekeeper. Okay, so here are the two paths, laid out side by side. On one hand, you've got the default deny strategy. We also call this whitelisting. It is super strict. The rule is simple. If your name's not on my list, you're not getting in, period. Then on the other side, you have default permit, or blacklisting. This is much more relaxed. Its philosophy is basically, hey, as long as you're not on my list of known troublemakers, come on in.
So, right away you can see the trade-off, right? Default deny, the whitelist, gives you way better security because you're only allowing traffic you know you can trust. But, and this is a big but, it's a ton of work to set up and maintain that list. Default permit is so much easier to get up and running. The problem is you're always playing defense. You can only block a threat after you know it exists.
All right, so now that we've set the ground rules for our gatekeeper, let's talk about how we actually build the fortress itself. Let's get into the different architectural designs.
The most basic design, the simplest one you can build, is the dual-homed firewall. Just think of it like a castle with one single, heavily fortified gate. Every piece of data, whether it's coming in or going out, has to squeeze through this one choke point. It's straightforward, sure, but if that one gate goes down, your entire defense crumbles.
Now, a slightly more advanced setup is the screened host architecture. This one's a little smarter. It still has that main heavily guarded gate, but it also creates a kind of express lane. For certain types of traffic that you already trust, you can let them bypass the main inspection. It makes things a lot more efficient.
But if you're looking for the most robust, most secure design, you're going to want a screened subnet firewall. Now, this is a whole other level. This architecture doesn't just build a wall. It builds a wall, then a courtyard, and then another wall. It's really the gold standard for protecting your most critical stuff.
And here's how it works. It creates three distinct zones. First, you have the external network, the Wild West of the internet. Then you have this middle ground, a buffer zone that we call the DMZ, or demilitarized zone. This is where you'd put things like your public website. And finally, behind another layer of security, you have your internal network. That's the crown jewels, where all your sensitive data lives. Now, the absolute genius of this design is that there is no direct path from the outside world straight into your internal network. It's blocked. So an attacker might be able to break into a server in that middle DMZ area, but guess what? They've just hit another wall. They can't just hop from there into your really important private network. But of course, no fortress is perfect. Attackers are relentless, and they're always looking for cracks in the wall. And trust me, they've come up with some incredibly clever ways to sneak past even the best defenses. You have to remember, firewalls have blind spots. They can't inspect what they can't see, which makes all the encrypted traffic flying around today a massive challenge. And they also depend on the very software they're trying to protect. If there's a bug in your web server, an attacker might be able to exploit that directly, and the firewall might not even see it happen. And that brings us to one of the biggest problems for any modern firewall. It's a technique that doesn't try to knock the wall down. No, it's much smarter than that. It just puts on a disguise and tries to walk right through the front gate, hidden in plain sight. This technique is called tunneling.
Tunneling is basically the digital version of hiding contraband inside a delivery truck that has all the right paperwork. The firewall sees the truck. It's a protocol it knows and trusts, so it just waves it on through, totally oblivious to the malicious cargo hidden inside.
A perfect example of this is HTTPS tunneling. Think about it. Every company has to allow web traffic, right? So firewalls are built to trust it. Attackers know this, and they use tools like ngrok to wrap up their malicious data inside this perfectly normal, trusted HTTPS traffic. To the firewall, it's completely invisible. And then there's something even sneakier, DNS tunneling. DNS is like the internet's address book. It's the system that turns a website name into an IP address. Your network cannot function without it, which means no firewall can ever block it. So attackers use tools to encode their data into these tiny essential DNS requests, creating a secret back channel that's almost impossible to detect or stop.
So what's the big takeaway from all this? Well, a firewall is absolutely essential. It's your first line of defense. But it is not a set-it-and-forget-it solution. It's not a magic box that solves all your problems. Real security is a process. It means constantly watching, updating, and understanding how the threats are changing.
And that leaves us with one final thought to chew on. If the bad guys aren't trying to smash down the gate anymore, but are instead hiding inside those trusted delivery trucks we have to let in, what does our wall even mean? How does our whole idea of a gatekeeper need to change for the future?